Yes?
Number 26.
26 on 3,3?
Yeah.
K is a constant. So S is the variable. So when you take the derivative, it's just going to be 1 plus k e to the s, or actually minus 1 plus k e to the s divided by s plus k e to the s squared. Does that make sense?
A little bit, yeah.
Well, remember the derivative of 1 over g of x is just minus g prime over g squared. So the derivative of s plus k times e to the s is just 1 plus k times e to the s, since k is a constant. Does that make sense?
Yeah.
Okay. What else? Yes?
Number 4, 3.4.
Okay. What's the problem?
You know, I think I got number 2, but I'm just not sure if I'm doing it.
By the way, the first sentence of number 4, I guess I didn't say anything last time about it, is equivalent. And I know you have a tendency to not necessarily read the instructions in general, so you may or may not have actually been confused by this. It says a bacteria culture grows with constant relative growth rate. The idea is that if you look at P of t to be your population, then P prime divided by P of t is equal to k, means that it has the left hand side is the relative growth rate. Why? The idea is p prime is the growth rate, we divided by p, and so it's relative to the size of the population. This is exactly the same way of just saying that the population satisfies an exponential growth. So it's basically just a different way of saying the same thing. So number 4 doesn't actually tell you the initial population, right? And so what it does is it actually tells you the value of 2 particular times. So what you just have to recognize is that, let's see, let me put it over here, is that P of t has to look like P of 0 times e to the kt. And now P of 2 is equal to 600. And then it says after 8 hours the count is 75,000. So P of 8 is equal to 75,000. So you technically have a system of 2 equations with 2 unknowns. That will basically be what it accounts for, because you have 600 is equal to P of 0 times e to the 2t, and then you have 75,000 is equal to P of 0 e to the 8t.
The number k?
Oh, sorry, yes. 2k and 8k. Does that make sense? Right? Okay. How do you solve this?
Do weird system equation stuff.
Hmm?
Do weird system equation stuff.
Weird. Well, what you can do is you can be creative with things, in the sense that well, I mean, it depends on how you want to look at things. You can solve for P0 and put it in the other equation. That would be one way, right? If you solve for P of 0, that's just going to be 600 e to the minus 2k, right? And so from here, 75,000 is equal to 600 e to the minus 2k times e to the 8k. So 750 divided by 6, which obviously can divide, but anyway, 750 divided by 6, or maybe I should divide that. What do we get? 250, 25 times 5, 6. 125, right? Is equal to e to the 6k. So from here, clearly, you can figure out what k is, and then you can figure out what p of 0 is, right? Technically, part A asks you for the population, for the initial population. So I could have actually maybe proceeded in a different way to actually get the population directly without actually coming up with k. But as it turns out, part B asks you for the the actual original function, p of t equals everything. So you're going to have to come up with k anyway. Yes.
Why does the 2k change to negative 2k?
Well, what happens when you solve for p of 0? How do you solve for p of 0?
You have to find k.
No, I'm saying how do you solve for p of 0? You divide both sides by e to the 2k.
Oh, okay.
So what happens when you divide by e to the 2k? Technically it's 600 over e to the 2k, right?
So basically we're saying them both equal to each other, moving all the way over.
Well, they are equal to each other. I'm solving for p of 0. Remember, there's two ways of solving systems of equations. One way is elimination, the other one is substitution. Well, clearly I can't eliminate things here because it's actually a product. It's not a linear system of equations, right? The function of k and function of p actually are multiplied by each other. So usually the way to approach these types of systems of equations is substitution. You solve for one variable and you plug it in the other equation. Is this making sense? Should I be confident that you can do everything else? Well, I'm hoping everybody can solve for k here, right? Once you solve for k, I'm hopeful everybody can figure out what p of 0 is, right?
Oh, wait, that gives us our k value, but where do we find our initial value, initial population?
What is this called? The initial population. P of 0 is 600 e to minus 2k.
Oh, okay, so then we just plug in k.
So once I figure out what k is, which is ln of 125 over 6, right? Does that make sense? So I think P of 0 is 120. Right? I don't know. Anybody actually solved it? 120? You have to be sneaky about it. K is ln of 125 over 6. And so when you look at P of 0, you end up with 600 e to minus 2 times ln of 125 over 6. Right? And now, of course, you can take out a calculator if you really want to be creative. But the one thing to recognize is that this is not really a number. So, obviously, the book doesn't tell you that you should simplify things, right? That just asks you for the initial population, and technically this is the initial population. But can you tell me what this is? If you look at it in this form, what is the initial how much did I start with? It's not like, this is a number that you can actually, assuming you work in the real world, this is not a number that you could go to your boss and say, oh yeah, I solved it. This is the number that, you're looking at. Right? Does that make sense? Yeah? As anyway, so the idea is you have to be a little creative with things, but as it turns out, it's actually very nice, because this is just minus ln of 125 over 3, which is the same thing as 600 e to minus 1/3 ln of 125, which equals 600 e to ln of 125 to negative a third. What's 125 to negative a third? Not quite, very close to 1/5. So you end up with 600 over 5, so you end up with 120. As I said, you just have to be a little creative. Is this making sense? Yeah? I'm fairly confident you can figure it out from here on, right? Okay. Alright, what else? Okay, so then today we're going to go into the wonderful world of inverse trigonometric functions. So let's start off with f of x equals sine of x. Now this is something that you've done in the past, right? Inverse trigonometric functions are something that you've done in the past. But the bigger question is, do you remember anything from them? What is the domain of sine of x? And I guess I was thinking about it, so I gave you the answer. The domain is all real numbers, right? What is the graph of sine of x? Sound effects are nice. So, let's see. Pi over 2, pi, 3 pi over 2, 2 pi, and I'll go to minus pi over 2 over here as well. Right? Does that look familiar? I'm hoping. That's a big assumption. Okay, now, is this function one-to-one? No. So in order for me to talk about an inverse, I need to actually limit myself to a one-to-one function, right? So how should I do that? And the answer is, because sine is a periodic function, there's a variety of ways in which you actually can limit yourself to a one-to-one, or to a piece that's actually going to be one-to-one. In general, we would like to include zero in things because it makes life simpler, and so as a consequence, we're going to be focusing on this piece. Which means sine inverse of x is equal to y is equivalent to saying sine of y is equal to x, and y has to be between minus pi over 2 and pi over 2. Does this make sense? Do you remember this at all? First of all, I'm hoping I don't have to write it again. Sine inverse of x is not 1 over sine of x. Yeah? Okay? So that would be one thing. Alternatively, sine inverse of x is also written as arc sine of x. So, also, what is this actually telling us? If you're asked for, and this is where I remember from the pre-test, a lot of you messed up. If you look at sine inverse of x, your answer, so if I ask you what's sine inverse of 1, the answer has to be between minus pi over 2 and pi over 2. Okay? Is that clear? So, if I ask you what is sine inverse of pi over 4, pi over 4, sine inverse of root 3 over 2, I changed it so it's not pi over 4 anymore. Do you remember how to do this? We name this y, and so the question is, sine of what angle gives you square root of 3 over 2? And y is pi over 3. Does that make sense? Now, what if I ask you what's sine inverse of minus 1/2? Again, this is a question. Negative pi over 6. Is that making sense? Yeah? Okay. Wonderful. So, I guess we should point out that sine inverse of sine of x is equal to x, and sine of sine inverse of x is again equal to x. Right? Now, on the top, x has to be limited between minus pi over 2 and pi over 2. On the bottom, what would you guess the limits on the x should be? Between minus 1 and 1. Does that make sense? Remember what you're actually looking at. Here, regardless of what this quantity inside is, sine inverse of that quantity is equal to x. Well, sine inverse is defined to be between minus pi over 2 and pi over 2. That's how we defined sine inverse. And so those have to be the limits on x. If you go down here, you have sine of whatever this is. Well, sine of any angle will be automatically between minus 1 and 1. That's how sine of x is defined. Is that making sense? Okay. Let's see. How should we approach this? Do you want me to go through all trigonometric functions first and then show you their derivatives? Or do you want to see the derivatives as I go through each of them? I know, choices. Number 2? So each function and then its derivative? Okay. So then the question would be, what is the derivative of sine inverse of x? Let me quickly squash any thoughts about the fact that the derivative would be cosine inverse of x.
That would have been off.
Okay? As it turns out, the derivative has nothing to do with any trigonometric function. Okay? The answer will be 1 over the square root of 1 minus x squared.
That's weird. At least.
Now, how do we get to it? So, how do we get to the derivative of e to the x? Do you remember?
It stays the same.
How did we get to it? I understand it stays the same, but how do we actually figure out it stays the same? How do we came up with the derivative of a to the x? So we have the following. Sine inverse of x is equal to y is equivalent to sine of y is equal to x. Now if we take derivatives in both sides with respect to x, what do we get on the left hand side? Cosine of y dy over dx is equal to 1, right? So dy over dx is equal to 1 over cosine of y, right? So technically the derivative of sine inverse of x is 1 over cosine of sine inverse of x. Well, it doesn't look very nice, right? So what we're going to do is we're going to ignore that. And we're going to come back to the fact that to the fact that sine of y is equal to x. Right? Okay? Now how should we approach this further? Well, remember, sine squared of y plus cosine squared of y is equal to 1, from which cosine squared of y is equal to 1 minus sine squared of y, from which cosine of y is equal to plus or minus the square root of 1 minus sine squared of y. Right? Now, plus or minus, the idea is y lives between minus pi over 2 and pi over 2. Cosine of y will be always positive. Right? Everybody remembers this? Cosine is positive in the fourth and the first quadrant. So that means, because y is between pi over 2, negative pi over 2 and pi over 2, this means that cosine of y is equal to the square root of 1 minus sine squared of y. But sine of y is equal to x, so that's equal to square root of 1 minus x squared. Right? Do you understand how to do this? You have to do it for the homework. We're only going to derive sine and cosine, and let me see. You have to derive secant inverse. I guess you got lucky because out of the 3 problems that require them, 2 of them are odd. So you will have to derive the secant inverse of x, the derivative of secant inverse. But before I go any further, is this making sense? Yes?
I use the last. I use the x squared.
Sine of y is equal to x. So sine squared of y is just x squared. So all I'm doing is just replacing this quantity with x squared. Yeah? So we showed that the derivative was 1 over cosine of y, but that's just going to be 1 over the square root of 1 minus x squared. Is that making sense? Yes? Barely? And as it turns out, we actually lose 2 points for the domain. The domain of sine inverse of x was between minus 1 and 1, where minus 1 and 1 were actually points that we could use. But because of the denominator now, we lose minus 1 and 1. Also, if you think about it graphically, do you know what the graph of sine inverse would be? I'll take that as a no. So the idea is, this is going to be y equals sine of x, where this point is pi over 2, this point is negative pi over 2. So when you reflect this along the line y equals x, instead of having the point there, you end up with minus 1, 1. pi over 2 and negative pi over 2. And we start on the bottom here, right? And how do we go? We'll go this way and end up there. Is that making sense? Yeah? Okay, now if you just actually inspect it very, visually, notice that at negative pi over 2 and of pi over 2, you'll actually end up with a vertical tangent. Since the tangent is vertical, the derivative can't actually exist. Right? That means the derivative is infinite. Right? Which is exactly what we actually gather from here. Right? If you put in 1 in for x, you end up with 1 over 0, which shoots to infinity. So you end up with a vertical tangent. Is that making sense? Okay. How about y equals cosine of x? So again, if I actually am to draw the graph of cosine, we have pi over 2, pi, 3 pi over 2 and so forth, minus pi over 2. So that would be my graph. And now again, this is not a one-to-one function, right? So what should we focus on? Zero to pi. And so y equals cosine inverse of x is equivalent to x equals cosine of y, where y is between 0 and pi. Is that making sense? Yeah? Okay. So then what is cosine inverse of square root of 2 over 2? Pi over 4. And what is cosine inverse of minus 1/2? Sorry? Over 3? Two pi over 3. Right? Because cosine of pi over 3 is 1/2. Right? And so you basically have to move on the other side because you have to be in the second quadrant. Right? Does that make sense? Yeah? No? Cosine of 2 pi over 3 is equal to minus 1/2. And so that means cosine inverse of minus 1/2 is 2 pi over 3. Now why is cosine of 2 pi over 3 minus 1/2? You could technically memorize it, or you could just remember the fact that cosine of pi over 3 is equal to 1/2. Right? Now cosine and so basically what you do is you can think about, if you wish, think about your circle. You're at pi over 3. This is pi over 3. If you reflect it over the y-axis, this is pi over 3. So cosine inverse of minus 1/2 is pi minus pi over 3, which is 2 pi over 3. Does that make sense? Yeah? This is obviously not the only way you can think about things. As I said, when we looked at a review of trigonometric functions, I told you there's a variety of ways in which you can think about these things. Okay. So, what would be the derivative of cosine inverse? Should we derive it? Let's. Okay. So y is equal to cosine inverse of x is equivalent to saying cosine of y is equal to x. Now you take derivatives in both sides with respect to x. What do we end up with on the left hand side? Negative sine of y dy dx is equal to 1, right? And so dy dx is minus 1 over sine of y. So now all we have to do is figure out the relationship between sine of y and x. So remember, sine squared plus cosine squared is equal to 1. Sine squared of y is 1 minus cosine squared of y. So sine of y is plus or minus the square root of 1 minus cosine squared of y. So now the question is it positive or is it negative? Y lives between 0 and pi. Sine is positive between 0 and pi. So this becomes sine of y equals the square root of 1 minus cosine squared of y. Yes? Which is square root of 1 minus x squared. So I'll come over here and give you the answer. It's just minus 1 over the square root of 1 minus x squared.
Same, just the range.
The range will be the same, because the only difference is the minus. The range will be the same because, again, cosine lives between minus 1 and 1. So x will live between minus 1 and 1. Remember, the range of cosine is going to be the domain of cosine inverse. And the range of cosine is between minus 1 and 1, because that's what a trigonometric function does, right? It's bounded between minus 1 and 1. And by a trigonometric function, I mean cosine and sine, since those are the only ones that are bounded. Is this making sense? Assuming that you care. Yeah? Okay. So, how about tangent? I'm guessing for the tangent, you remember the graph? Everybody remembers the graph of tangent? Let's write it out since. So the idea with it is that it has vertical tangents at all multiples of pi over 2. Again, clearly it's not a one-to-one function, but it should be an obvious way of actually making it a one-to-one, right? We'll just focus on that particular piece, right? And so y equals tangent inverse of x is equivalent to x equals tangent of y, where y lives between minus pi over 2 and pi over 2 without actually being equal, right? That's the difference between tangent and sine.
Wait, what did you say?
I said there's no equal here. Y can't be negative pi over 2 or pi over 2 because those are vertical asymptotes. Okay? So now, should we play this? I think we played this game long enough. What is the derivative of tangent inverse? One over something? That's very good. 1 over what? 1 over 1 plus x squared. Should we see how or why? It turns out it actually is very obvious. It's going to be much simpler, yes.
All this learning why, does that have anything to do with homework? Like, on the homework, I see it's mainly using finding the derivative, and then we'll probably be getting product and quotient changes, right?
More or less.
So we aren't really, it's good to understand why it's equal to that, but like, we don't really have to use any of this math to solve problems. Any of the math tips.
Well, I told you, number 14, for instance, asks you to find the derivative of secant inverse, or to show that the derivative of secant inverse is 1 over x times the square root of x squared minus 1. How do you think you're going to do that? Answer? This way. Or am I going to end up doing that as on Monday or on Wednesday? Actually, never mind. This is actually due on Wednesday. Okay. The reason why I'm going through all of this is besides the actual derivatives, so you can actually see where they're coming from, is there's two things to this. First of all, me showing you how to do these should come in hand at the test if you, for example, don't remember what the derivative of an inverse trigonometric function is. It would be relatively easy to remember how to derive it, I would assume. That's number one. And number two, I want to show you the whole point of me teaching you here is actually teaching you how things come about, and not here's the formula, now apply it, because then you could be teaching that to yourself. You know, open up the book, here's the formula, now apply it to 50 different problems. And so that's basically why we're spending the time and actually explaining things and not just actually writing them out. Does that make sense? Okay. How do we show that this is 1 over 1 plus x squared? Well, as it turns out, it's actually very easy. Y equals tangent inverse of x is equivalent to saying tangent of y is equal to x. And if you take derivatives in both sides, you end up with secant squared of x times secant squared of y times dy over dx is equal to 1. So dy over dx is 1 over secant squared of y. And now trigonometric identities give us that, how should I write this better? 1 plus tangent squared of y is equal to secant squared of y. And so if we come up here, this is just going to be 1 over 1 plus tangent squared of y, but that is 1 over 1 plus x squared. Notice there's no more square roots. What is the domain of tangent inverse of x, by the way? All real numbers? Right? Think about your graph of tangent. If I reflect this over the line y equals x, I'll start here, go up, and then just shoot to infinity. Or, I guess, I'll go to pi over 2, but x can go to infinity. Okay. So, let's put them all together. Let's make it in this. Yeah, I'll just do it this way. d over dx of sine inverse of x is equal to 1 over square root of 1 minus x squared. d over dx of tangent inverse of x is equal to 1 over 1 plus x squared. d over dx of secant inverse of x is equal to 1 over x times the square root of x squared minus 1. I'm writing them in a particular order again for the reason that I showed you when we looked at derivatives of trigonometric functions. So the derivative of cosine inverse is minus 1 over square root of 1 minus x squared. The derivative of cotangent inverse of x is minus 1 over 1 plus x squared. The derivative of cosecant inverse of x is minus 1 over x times the square root of x squared minus 1. So again, I'm writing them in the same fashion I wrote them in the previous time when I talked about trigonometric functions, in the sense that on the right hand side you have all the cofunctions, and notice they all have the minuses in front of the derivative, as the trigonometric functions did. Okay? I guess there's a table for these on page 179. Okay, so let's look at some problems now. How about number 1? It says sine inverse of root 3 divided by 2. Now let me tell you one thing. Obviously, this is your homework, right? You're going to have problems like this for homework. It's not like I'm going to be watching, over your shoulder to make sure you're not using a calculator for this. You obviously can use a calculator for this. However, there are no calculators allowed in the exams. So using a calculator for this without understanding why it's equal to whatever it is not going to help you when the exam comes around, and I'm going to ask you pretty much the same question. Okay? So, how do we solve something like this? We have to figure out what angle, sine of what angle gives you square root of 3 over 2, right? And the same boundaries work, yes. Sine is between minus pi over 2 and pi over 2. Cosine is between 0 and pi. I guess I never told you about secant and cosecant, but those are usually bizarre. That's why I kind of skipped them. Pi over 3? Okay? Is that making sense? Should I do another one of these, or do you see how they work?
Oh wait, all we do is just look at the unit circle.
Okay.
The sine of y equals 3 over 2.
Yes. As long as you remember what your range is. That's the key important fact.
Wait, why is that important?
Because your function has to be 1-to-1. That's where that's where your inverse function is defined. Okay, how about part A? Sine of sine inverse of 0.7. 0.7? Why?
Because sine undoes this inverse.
Okay. How about part B? It says tangent inverse of tangent of 4 pi over 3. Pi over 3, you say?
4, 5.
That's pretty Wait.
How should we do this? Well, there's two ways of thinking about this thing. What is tangent of 4 pi over 3? Remember, tangent is periodic of period pi, right? So if I ask you for tangent of 4 pi over 3, in essence I'm asking you for tangent of pi over 3, right? Which is? Root 3, you say? Remember, tangent is sine over cosine. We just discussed the fact that sine of pi over 3 is root 3 over 2. So it'll be root 3 over 2 divided by 1/2. So just get root 3. And now what is tangent inverse of root 3? Pi over 3. Does that make sense? Again, the focus of this particular problem is, yes, these functions are opposites of each other, so they cancel out and you have left with the argument. That is, if the argument is in the domain of tangent, or I should say, in the range of tangent inverse. And so you have to have between minus pi over 2 and pi over 2 as your answer. Is that making sense? Okay. Let's see. Okay, how about we look at number 7. It says, show that cosine of sine inverse of x is equal to the square root of 1 minus x squared. So how should we approach something of this nature? So, any thoughts? Let y equal sine inverse of x. Obviously, this means that x is sine of y, and y lives between minus pi over 2 and pi over 2. Right? Does that make sense? Well, no, we haven't actually answered anything yet. Right? Okay, so now, here comes a lovely graphical interpretation. If this is y, can you tell me what I just wrote above? How does that relate to my triangle? Let me make it a nicer looking triangle over here. I wouldn't say this is nicer, but anyway. How does that relate to my triangle? Sine of my angle is equal to x, right? Which means this is x, and the hypotenuse is 1, right? Do you see this? So what is the other side? Well, it's going to be the square root of 1 minus x squared, right? I'm looking for cosine of sine inverse of x, which means I'm looking for cosine of y, which means it's going to be the square root of 1 minus x squared divided by 1. So I showed what I wanted to show. Is this making sense? For number 8, which is your homework, you're going to have to find an expression for tangent of sine inverse of x. And then also you're going to have to find a formula for cosecant of arctangent of 2x. So should we do another one of these? Okay, how about number 9? We have sine of tangent inverse of x. So we actually don't know what it is now, so we have to figure out what it is. So do you remember how we set it up? We started off with y equals tangent inverse of x. This is equivalent to x being equal to tangent of y, right? So then, how is that relating to my triangle? I don't necessarily like the way your textbook does these things, so I'm gonna actually readjust. And I'm gonna name them theta, so we actually know for a fact that we're talking about an angle. It doesn't matter, you can leave it as y as well, obviously. So if this is the angle theta, then what do I know about tangent of theta being equal to x? One of your favorite things I keep seeing on all the tests, and I can never remember exactly what it's called. Was it SOHCAHTOA? So what does that tell you? That this is x and this is 1? Right? And so the hypotenuse is going to be the square root of 1 plus x squared, or x squared plus 1.
How did you know that in both of those triangles that was 1?
Well, because you want to have it as a fraction, right? Because that's, all your trigonometric functions are going to be either the hypotenuse or over, one of the sides over the hypotenuse or the side over the side or whatever the situation may be. So you want to be able to write it as a fraction. Well, x is just x over 1.
Well, how come it's not x over square root of 1 minus x squared like it was previously?
Well, there I have sine of y being equal to x. So I actually didn't know this side. I knew x and I knew 1. And then I just came up with this. See here again, I knew x and I knew 1, and I came up with the hypotenuse. Yes?
How did we come up with the hypotenuse?
Pythagorean theorem. Maybe I should have pointed that out. For both of them, the way you come up with it is the Pythagorean theorem. I bet when you were in, 7th, 8th grade, when you were taught the Pythagorean theorem, you didn't think it's going to come back so many times? I don't know, was it 7th, 8th grade?
More like 9 or 10.
9th or 10th?
So is there any relation to the derivative of that?
No, these have nothing to do with the derivatives. We haven't gotten to the derivatives yet. But especially if you need to take Calc 2, this is going to come back and bite you if you don't know what they are. What?
I guess I'm just confused because you see Pythagorean theorem, the one above it, I would like x squared.
So if this is a, right? Pythagorean theorem tells us that 1 squared is equal to a squared plus x squared. So a squared is 1 minus x squared.
Yeah, but how did you assign 1 to the top?
Again, sine of y is equal to x, right? Which means I need to figure out which one is the side and what's the hypotenuse. Well, if it's x, it's the same thing as x over 1, right? Which means the opposite has to be x, the hypotenuse has to be 1.
I'm not getting that.
Why not?
Okay, so we have x equals sine of y, right?
Yes. So, sine of theta is equal to x. If I draw my triangle, and I'll do it the other way, maybe it'll be more apparent. What is sine of theta telling me as far as my triangle is concerned? It's the opposite over the hypotenuse, right? So if I name these A, B, and C, sine of theta has to be A over C, which equals x. What can possibly be A? What can possibly be B? The only way they can work is if A is equal to x, sorry, not B, C, and C is equal to 1. I mean, of course, if you like ugly numbers, A can be 1 million x's and C can be 1 million. Clearly, A over C will give you x. Right? I'm just choosing x over 1 because that's the simplest one you can go with.
Okay, so we look at SOHCAHTOA depending on what are trig functions.
I don't like assigning letters to things. So yes, you're looking at the definition of cosine, definition of sine, definition of tangent. Yes.
Very improficient in trig.
So A is equal to x, C is equal to 1. So now what is B? Well, C squared is equal to A squared plus B squared. So 1 squared is equal to x squared plus B squared. I need to figure out what B is. So B squared is 1 minus x squared. So B is the square root of 1 minus x squared. Right?
Okay.
So now if we come back to the top one to finish it off, can you tell me what sine of tangent inverse of x is? It's the same thing as sine of theta, right? And all I have to do is just pick it up from the triangle. It will be x over the square root of 1 plus x squared. Does that make sense?
Oh wait. So it's like we're plugging in at, or no. Multiplying x by...
First step is, I named tangent inverse of x to be theta. That's equivalent to x being equal to tangent of theta, or tangent of theta equal to x. Put that in the triangle. This means that this is x, this is 1. Again, if you want to be creative, this is a gajillion x's, this is a gajillion. Do the Pythagorean theorem. It'll give you the square root of 1 plus x squared. And all I have to do is come back. Tangent inverse of x is defined to be theta, so in essence I'm looking for sine of theta. Look on the triangle and figure out what your ratio is going to be. Okay? Wonderful. So let's take some derivatives, since I know you've been dying to take some derivatives. 17 on page 180. Y equals tangent inverse of the square root of x. So what is dy over dx? Two words. Second word is rule. First rule is chain. One over 1 plus whatever quantity I have here squared times the derivative of my quantity, which is going to be 1 over 2 times the square root of x. Does that make sense?
That makes sense.
Yeah? Okay. 19. Since you have so much fun, y equals sine inverse of the quantity 2x plus 1. dy over dx is, again, two words. Last one is rule, first one is chain. 1 over the square root of 1 minus 2x plus 1 quantity squared times 2. Make sense?
Simplify that? I mean, we can boil it, but...
If you expand it, I guess the ones will cancel, but it doesn't necessarily help out.
Okay.
21. Oh, this is a nice one. h of x equals the quantity 1 plus x squared times arctangent of x. And you tell me what the answer is, because it's going to be actually very simple. In this particular instance, we have two words. One of them is the same, but the other one's different. Again, last word is rule. First one would be product. So, what is the answer? Don't be so hasty. Nope. Again, product rule. Derivative of the first times the second plus derivative of the second times the first. 2x times arctangent of x plus 1. The derivative of tangent inverse is 1 over 1 plus x squared. And you multiply that by 1 plus x squared. Should I write it out? 1 over 1 plus x squared times 1 plus x squared. Well, this is just a fancy 1. Does that make sense? Okay. 23. Since we learned so many different functions, why shouldn't we just combine them? Cosine inverse of e to the 2x. So I'm waiting. Minus 1 over fraction. Square root of 1 minus e to the 2x squared, which is e to the 4x, times e to the 2x times 2. Wonderful. Does this make sense? Yeah? Okay. How about 25? Y equals arctan of cosine of theta. So dy over d theta is equal to 1 over Cosine of theta squared times negative sine of theta. Yeah? Okay. 27. H of t is equal to cotangent inverse of t plus cotangent inverse of 1 over t. So remember, cotangent acts the same way as tangent does. The only difference is you have a minus in front of it, right? So minus 1 over 1 plus t squared minus 1 over 1 over t quantity squared times negative 1 over t squared.
Oh wait, the derivative of 1 over t, right?
The last parenthesis is the derivative of 1 over t, yes. Now, do you want to see something interesting or cool, I should say? If you simplify this, do you know what you get? 0. Should we go slower with this? What happens if you distribute a t squared in the denominator? You end up with t squared plus 1, right? The minus times minus makes a plus. So the second fraction is just going to be plus 1 over t squared plus 1, but that's the same thing as 1 plus t squared. That's a minus, that's a plus. They cancel out and you end up with a 0. Does that make sense?
Yeah.
Okay. Let's see. I think you have to go all the way to 38, right? Yeah. Okay, well, you know. Ooh, that's a good one. 33. G of x is equal to x times sine inverse of x over 4 plus the square root of 16 minus x squared. We're supposed to find g prime of 2. So for this particular problem, there's a bunch of two-word statements. They all end in rule. Okay, so let's start off. What's the derivative of x times sine inverse of x over 4? Sine inverse of x over 4 plus one over square root of 1 minus x over 4 squared times 1/4 times x plus 1 over 2 times the square root of 16 minus x squared times negative 2x right? Yes?
Where does
Now, you can obviously put in 2 in for x and see what you're actually ending up with, right? Or we can observe that if we do some lovely algebra, g prime is just sine inverse of x over 4. It was rigged. Do you see that or not? Okay. Well, the 2's cancel with the 2. Right? Of course, I chose the easy part first. Now, what happens if you put in the 4 underneath the square root? So what happens if I take this particular 4 and plug it into inside the square root? So when you put in 4 inside the square root, it becomes 16. So you end up with square root of 16 minus x squared over 16 times 16. So the square root becomes 16 minus x squared, which is 16 minus x squared. The numerator is just going to be x. Here you have minus x. They end up being the same term, just the opposite signs, so they end up canceling each other. Right? This is, by the way, one of the benefits of actually simplifying things. Because if I am to give you this particular problem and ask you like domains or when is g prime equal to 0, well, try and solve this for 0 or try and solve this for 0. Clearly the latter is much easier, right? So now what is g prime of 2? It's sine inverse of 2 over 4, which is sine inverse of 1/2, which is pi over 6. Make sense? Wonderful. Okay. Well, we spent a whole day today and we haven't talked about limits. The limit as x goes to minus 1 plus of sine inverse of x. So, negative pi over 2, say? Yes? So the idea is what sine inverse of minus 1, right? So when is sine negative 1? Right? Okay, how about 37? The limit as x goes to infinity of arctan of e to the x. Yes? Pi over 2, you say? As x goes to infinity, e to the x goes to infinity. Right? So the question is, what is arctangent of infinity? And if you think about the graph, that will be the graph. So as x shoots to infinity, pi over 2 is a horizontal asymptote. Right? By the way, this is another one of those situations in which you may not see asymptotes when you look at the function, because it just is, tangent inverse is not necessarily like a ratio, or it's not necessarily that easy to notice. Okay, we're gonna stop here. Enjoy your homework.